Alright, let's make fractions a lot less scary for people. So we're going to look at 3/8, and we're just going to treat this fraction as our go-to fraction for this particular explanation. So what does this say ultimately is the question. So right away we need to understand that there are some components to a fraction. This is called the numerator, this is called the denominator, and right here we see this per sign, or this line that we're used to associating with fractions. And it could be like 3 at an angle 8, or we just see it as 3 like so. These are the same thing. And what this equals is a division symbol. And the way you can remember that is this dot's the numerator, this dot's the denominator, and here's that line. Alright? Now if we tilt that at an angle, we see that it looks like a percent symbol. And that's pretty handy because a fraction and a percent are the same thing. Something else to keep in mind is that a fraction and a ratio are the same thing, and a fraction and a decimal are the same thing. So let's look at what that means. So this is 3/8, or 3 per 8, or 3 to 8, or 3 divided by 8. Now if we go 3 divided by 8, does 8 go into 3? No. So we draw a decimal, we draw a 0, and we treat that 3 as a 30. And we're able to do that because we're just moving the decimal place one direction or the other, right? We're still going into 3, but we just pretend it's a 30. Does 8 go into 30? Sure it does. What is it? 8 times 4 is 32. I guess it'd be 8 times 3. Whoops. 8 times 3, which would give us 24. We subtract that and we find the difference, and it is 6. And then we say, does 8 go into 6? It doesn't, so we draw another 0 and we drop it down. And we say, does 8 go into 60? It does, 7 times. And then that would be 56. And then we subtract, and then that gives us 4 again. Or, not again, but now. And so we draw a 0 because it doesn't, 8 does not go into 4. And it becomes 40. So does it go into 40? Yes, 5 times. Now 5 times 8 is going to be 40. And it zeroes out. Okay, so we get 0.375. 0.375. Now that says tenths right here, hundredths, thousandths. This is 375 thousandths. Okay, so somewhere between 0 and 1 on the number line is this 0.375. Right? It's not all the way to 0, and it's not to 1. And we can see by the 0.3 that it's less than halfway to the 1 from the 0. Okay, now 0.375, as any decimal can be converted, moving the decimal 2 places to the right, can be converted to a percent. It'd actually be rounded to 38%, or we would say 37.5%. Now, once that percent symbol is added to it, it means that the decimal's been moved from the decimal position to the percent position. So if this percent sign is here and we want to convert it to a decimal, we simply 2 places back to the left, and it becomes 0.375. No percent sign included. Now as a ratio, this is 3 to 8. And this is a key element of a fraction, the fact that it is a ratio. And that ratio aspect, and the fact that it is a ratio, is what allows us to do what's called cross-canceling. And let's look at cross-canceling real quick. So here we see 3/8 multiplied by 2/3. Now, when it comes to multiplying fractions, we don't need to find a common denominator. We're just multiplying straight across. And we can do that, and we can say, okay, 3 times 2 is 6. Then we can say 8 times 3 is 24. Now, we see that these are both even, so they can be reduced, so we can take a factor of 2 if we wanted. We could actually take a factor of 6, but because they're both even, we can always just keep reducing by factors of 2. So let's do that here. And remember, a factor is when we have a number multiplied by some other number, we get a product. And this number is a factor, and this number is a factor, and then our answer is, of course, a product. So a factor of 2, we're going to divide that 6 by a factor of 2, and it becomes 3/12. Now, 3 is a prime number, so it can be divided by itself or 1, and we will do divide by 3 because this can also be divided by a factor of 3 evenly. and it becomes 1/4. Now, we could have originally just reduced that by a factor of 6 or divided that by a factor of 6 and got right to 1/4, and that would have been fine too. But I wanted to show that anytime the numerator and the denominator are both even, you could just keep going by 2's and you don't need to sit and overthink it too much. Now, the cross-canceling aspect and how it relates to a ratio. 3/8 multiplied by 2/3. And we've seen that it equals 1/4. We'll just put that over here because we know that's the answer. Now, what does this say? Because we're not finding a common denominator, we're simply increasing this 2 by a factor of 3, right? And we're increasing this 8 by a factor of 3. So if we're increasing the numerator by a factor of 3, and we're increasing the denominator by a factor of 3, we can simply cancel out those 3's, and we get 2/8. And just move that 2 over to the numerator position, or move the denominator over the denominator position, we get 2/8. Now, when we reduce 2/8 by dividing by a factor of 2 by a factor of 2, we get 1/4. And we see that it worked. So, why does cross-canceling work? Let's do one more problem to explain why cross-canceling works. So if we have 3/8 and we multiply by, let's say we multiply by 1/3. Well, let's do it. Let's do 3/8 multiplied by 3. Okay. Now 3/8 multiplied by 3. Now 3 is the same as 3/1, right? So if 3 is the same as 3/, actually, you know what? Ignore that little one. Let's go with this one. We know that we can cross cancel here, and we just explained because we're increasing by factors of 3. But I want to do a different one. I want to do, let's say we have 5x, and we're going to get rid of that, equals, let's say, 35. So 5x equals 35. We can see that x is 7, but we're going to go ahead and isolate this variable term, and what we do is we divide by 5 to get the 5 away from the x. And we use a cross cancel here. So here's an instance where we're using cross canceling. Whatever we do to one side of the equal sign, we have to keep the statement true, so we do to the other side of the equal sign, and then of course we get 7, so we see 7 is equal to x. Why does this work? Well, let's look. 5x is the same as 5x over 1, and this says divided by, right? Divided by 5, which is the same as 5 over 1. Whenever we multiply fractions together, we simply divide fractions together, we simply flip the second fraction and change this to multiplication. So let's go ahead and do that. So we get 5x over 1 multiplied by 1, make the ones look the same, 1/5. 1 is the multiplicative identity, which means anything we multiply it by 1 keeps its identity. So the 1 becomes redundant, and we get 5 here. Now let's break this down even further. Let's say 5 over, let's say 5 over 1 multiplied by x over 1, and that accounts for this right here, right? And that was accounting for this. Now it's divided by 5. Now we just talked about how if we divide by 5, that we flip the second fraction and then multiply. So we'll just do that right away. We'll multiply and then make it 1/5 instead of 5 over 1. And now multiplication is commutative, so I can go either direction. I can go this way or I can go this way. So we're going to go this way first, okay? And so 5 times 1 is 5. 5 times this one is 5. So we end up with 5 over 5, which is equal to, of course, 1 whole. We still have this x here. X times this 1 stays x, so no problem there. So we have 1 times x, which is equal to just x, because we have a coefficient of 1. 1 is a multiplicative identity. We end up with just x on one side. Now we have to, of course, still divide by 5 on the other side, which is 35 divided by 5, which gives us 7, so on and so forth. But we see why cross-canceling works. All right, cheers.